is to identify each and every nodes. So nodes, as per the definition, is the interconnection of two or more elements. Okay, but here you can consider two. You can like if two resistances are connected in series. In that case, you will consider it as a single node. Okay. Uh, like for example, this one where these two resistors are there. Okay, this is also a node because it is an interconnection of two elements, but uh, you can only consider it as a node. Okay, and write the KCL equations, but it will increase the number of equations. So if you can simplify the circuit, since just by the series connection of two resistors, you can add them and consider it as R1 and R2. In that case, you can avoid these extra nodes. Okay, considering the extra nodes for writing the equation. Otherwise, you have to identify the nodes. Then you have to assign unknown voltages to these nodes. Okay, unknown potentials at these nodes. Among all the identified nodes, one you have to consider as a reference node. Okay, or ground. Okay, or 0 volt. Compared to that uh, voltage, you are like uh, trying to find what are the voltages of the other nodes. Comparison or the baseline is the reference node. So this we have already seen. Uh, and now consider some of the different cases of this nodal analysis. When there is a voltage source. In mesh analysis, what we did that if there is a current source in a particular mesh. Okay. Similarly, here in nodal analysis, we will see if this particular case where there is a voltage source. Okay, this okay. If you identify the nodes, what are the nodes here? Node one. Again, this you consider as a node. Okay, this you can consider as a node, but we will consider as a single branch. This branch we will consider as a single branch. This we are not considering as a node because it will over means it will just make lead to extra equations that you need to solve. Okay, so we'll consider this as a particular branch. So this is a node, this is a node, and this since there is no element here, this you can consider as a unified or single node. Okay. And the second thing, which one you need to consider as a ground. Okay, the thumb rule is, okay, you may not follow this rule every time, but to simplify the analysis, the rule is consider that node to be the reference node which has maximum number of branches ending at that particular node. Okay, that means here if you count the number of branches are 1, 2, 3. Again, at this node, okay, this we can also consider as a single node. Okay, because there is no element here. So there is a single node because there is no element. These two are a single node. You can just consider as a single node. Okay, and this is also the same thing. Now both the nodes, this node and this node will have the same number of branches ending to it. So you can consider any node as the reference node. Here we are considering this as the reference node. Okay, this one. Okay, this is the grounded. That means this is a reference node. This is a single node, node one, and you have to next you have to assign a unknown voltage to this node. Okay, you're assigning an unknown voltage V1, let us say. So V1 is unknown. So you're applying KCL at this particular node. You're applying KCL at this particular node. Let me write here. Please, whenever you will face any doubt, then and there, you just raise your queries. Okay. So here, This is your circuit. So what you can see that this is a single node. This is a single node. That is node 1. This is another node. That is node 2. Okay. Now, if you count the number of branches that are like ending in this node 1 and node 2, they will be same. So you can consider any of this node to be a reference node or ground. Okay. So we are considering the node 2 to be at ground. Okay. So then node 1 has some unknown potential. So we will consider that V1 is the unknown voltage at node 1. So now we apply KCL at node 1. Okay. Apply KCL. So if you apply KCL, then you have to see that what are the currents that are coming out of that node, what are the currents that are going into the node. Okay, here, if you see this branch, okay, if you see this branch, there is a voltage source, there is a resistance, and V1 is unknown. So if V1 is greater than 50 volt, then current will flow in this direction. If V1 is less than 50 volt, V1 is less than 50 volt, then the current will move in opposite direction because current flows from higher potential to lower potential. So if V1 is less than 50 volt, the current will be in this direction. Now, which one to take? Because we don't know V1, we have to find V1. So the convention is, or the assumption we will take is when we are considering a particular node, the voltage at that particular node is the highest one compared to all other voltages. So V1, we'll consider V1 to be of highest value. Then this case is correct. That means the current will be going out of this node. Then what will be the amount of current? That will be, what is the potential difference? Potential difference is V1 minus 50 divided by V equal to IR, I equal to V by R. The same thing here. So the net potential across this resistance will be V1 minus 50. And what is the resistance? That is 5 ohm. And in which direction is flowing? It is flowing out of this node. So if you remember the sign convention we have used in KCL, if it is going out of the node, current is going out of the node, then we consider it as positive. If it is moving into the node, we will consider it as negative. Okay, so current is going out, so positive plus sign. Then if you consider this node, this is a simple. Okay, there is a simple 10 ohm resistance. Okay, 10 ohm resistance. Node 2 will be at 0 volt. Now V1 will consider to be highest. So V1 will be greater than the this ground or 0 voltage. As a result, current will be flowing out. So that means plus sign. Okay, and what will be the current? V1 minus 0 divided by 10. Again, see this. This is the same node. Since there are no elements here, this node and these are same. This is a single node. So we'll consider now what is the current flowing through this 40 ohm resistance. Again, the same thing. V1 will be the highest. Current will be flowing out. So plus sign V1 minus 0 divided by 40. Next, this one. Here, there is a current source. So current is already given. All these things are current. V1 minus 50 by 5, V1 by 10, V1 by 40. These are all currents. So, but in this branch, already there is a current source, 3 ampere current source. Okay. And it is moving into this node. It is moving into this node. So it will be minus 3 and the sum will be equal to 0. Okay. Conservation of charges. The amount of charges that are going into a node, the same amount of charges that will be flowing out. And if you take that this amount of charges is flowing in and out for this much amount of time, that means dq by dt, that means current. So the same thing we are writing. Now there is a single node, single unknown, single equation. You can already find out what is V1. So using this equation 1, you can find out what will be your V1. So in this way, you have to tackle if there is a voltage source in any of the branches, you have to tackle like this. So from this you can find out what is the volt. Next. Okay. This is the next kind of circuit. Let me just let me know if you have any doubts. Okay. So now this is the next kind of circuit where there is a voltage source. If you can consider this a node, but again, the other way of solving this will be just add this 6 and 10, 6 plus 4 ohm. In that also we can do, but we are considering a special case. Let us consider that this is a particular node. This is node 1. This is node 2. And between node 1 and node 2, there is a voltage source. In the earlier case, if you remember this, here the voltage source was connected, one part was connected to the ground, the other part was connected with this some kind of a node. Okay, here the voltage source is between two nodes, but definitely there is other ways to solve this. We'll see that later, because if you, yeah, okay, yes, forgot to record this.
Recording in progress.
Okay, so these two are node 1 and node. Pay attention in the class. You may get the recording, but it will be of no use. If you are already there in the class, please stay, because here you can ask questions and everything. Okay, you may later see the recordings, but that is less effective than you are involved in the class, you are asking questions. That is much better than seeing the recordings. Um, uh, 1 and node 2. Okay. And now there is a voltage source that is connected between node 1 and node. That volt. Okay. Then how to write the equation? So similarly, you are writing CL at node 1. You write at node 1 this one. Okay. 3 ampere current source. So in KCL, I am only writing the current. That means what is the current through this path? What is the current flowing through this part? What is the current flowing through this part? What is the current flowing through this part? These are all current. That is the first thing you need remember. Okay, these are all currents. Itself is giving the what is the current value and the direction. For all cases, we have to find out using R to V by R formula. We are finding out what is the current. But the current source, it is itself giving what is the direction and what is the is given like this, and the value is 3 ampere. No need to write this kind of equation V by R. V by R is for those branches where there is a resistance or some other, if there are some other elements, use this like Ohm's law equal to IR. But when itself the current source is given, then there is no need to write this kind of equation. So this is B and C. This is branch D. So what I am writing, IA plus IB plus C minus I, that should be equal to 0. IA we are finding out like this. IB we are finding out like this. I this one ID is given to us. So that's why. So this is coming from KCL, Kirchhoff's current law. Okay, and what are the, yeah. So in the next part, you are writing the KCL equation for node 1. So V1 is you are assigning some unknown voltage, and this you have considered as ground. Be it using the thumb rule, that means the number of branches that are ending at this particular node, or by your choice. Okay, in whatever way you can do. So you are assigning an unknown voltage V1 at this particular node 1. Then you are writing KCL equation. So you have to consider the current flowing through this path, current flowing through this path. Now the direction you have to see. Now, if you consider this branch, then you are seeing that there is already a current source. Now, current source is itself giving the value of direction. This current is moving out. The current source, this current is will be moving out. So plus sign. What is the current? 5. Okay. Then through this branch, you now there is only a resistance. V1 is unknown. You don't know V1, then the current direction. For that, we are, if you are considering node 1 and you are considering the voltage V1 to be, V1 should be the highest voltage compared to other voltages, other node voltages. Okay. So if V 0 volts, if the current will flow direction. So in that case, plus sign moving out of the node. So V1 minus 0 divided by 10. Again, now this is the node, this branch where you need to write this equation. So we don't know V2. Okay, these elements 4 ohm and 10 volt, this lies in between this node 1 and node 2. Okay, you don't know V1, you don't know V2, but we know V1 we have to consider, since we are writing this for node 1, we will consider V1 to be the highest one. Then definitely V1, this and this 10 volt is getting, okay, this is plus sign, this is minus plus. So V1 will get added to 10 volt, and that will be greater than V2. Okay, so what is the net voltage that is being applied across the 4 ohm? On one side, it on this side of this 4 ohm, on this side 10, that is the voltage. On this side of the resistance, what is the potential that is being applied? V2. Okay, what is the difference between two sides? V1 plus 10 minus V2. And what is the resistance value? 4. So this will be the amount of current that will be flowing to the 4 ohm resistance. And what is the direction? Because we have considered V1 test, the direction will always be in this. So plus sign moving out of this node. So plus sign. So net thing will be equal to 0. So this you will get when you apply KCL at node 1. Similarly, if you apply KCL at node 2, then what will happen? You have assigned some unknown V2. Okay, so V2, since we are considering node 2, we will consider that V2 to be the highest one, highest voltage among all other voltages. Definitely we get that case current will to lower potential, the current will be in this direction. So V2, what will be the, since the direction is going out of this, for our convention, that will be, and what will be the value? V2 minus 0 divided by 6. Again, what is happening in this side? What is happening this? Now V2 we have to consider the highest. Now on this side of the resistance, V2, on this side it is V1 plus 10, but now we will consider that V2 is greater than this. So what is, in that case, the current will be flowing in this direction. So plus sign going out of the node. So plus sign V2 minus V1 plus 10 divided by 4. That will be equal to 0. Okay, same equations. So now two equations. This is equation 1. This is equation 2. What are the unknowns? V1 and V2 are the unknown. You can solve the simultaneous equation and you will get the answer. Yes, if you have any doubt, this is the second case that there is a voltage source in one of the branches, but that branch is between two nodes. In the earlier case, there is a voltage source, but one terminal of the voltage source was connected. Okay. Please look at the circuit, removing these things, look at the circuit and try to see whether the equation that are written, you are means through your understanding whether these equations that are written that are correct or not. Okay. We'll move ahead with our most important case. In mesh analysis, we did the concept of super mesh. Nodal analysis now called super node. So these two concepts are very important in from the perspective of competitive examination. Again, you will be reading these things in your network analysis. But yes, or please unmute yourself and speak. Okay, so there is this concept called supernode. That means in the previous case, you saw that there is a voltage source that were connected here. The voltage source was connected, but the voltage source connected between V1 and V2. But there is also a resistance. As a result, you can consider some current flows through this part. But now there is a voltage source between two nodes, being second and third node. Please mute yourself. Please mute yourself, whoever. Yeah. Now the voltage source is there, and the voltage source is directly connected between the second node and the third node. There is no resistance here. In that case, how will you write the current? What is the current flowing between second and in that case? Okay, there was a resistance here, and you are adding this voltage source with V3, and we will be able to find out what is the current flowing through this node. But here there is only a voltage source. So how you can find out how much current is flowing? Okay, this is a direct connection between, and there is a voltage source. If voltage source was not there, then V2 and second and third node would be a single node. But now both the cases are not applicable. That second and third are the same node. That case also you cannot consider because there is this current, there is this voltage source in between second and third, and you cannot also find out the current. What is the flowing through the branch between the second and third node because there is no resistance. How will you write the equation? Okay, in that case, how to deal with this problem? Concept called supernode. Okay, as in our super mesh, we temporarily remove the current source, the whole like two meshes to be a single mesh. That was the here also we will not consider the voltage source. We will not consider the voltage source, and we will consider the second node and third node to be a unified node. Okay, so okay. So this we can consider as a node. So this is node 1, this is node, this is 3, and this is our reference node. Okay. So let us start. Let us start by writing the KCL node 1. So this is a simple case. In node 1, there is no concept of supernode. Everything is simple. So how many number of branches are like there in this node 1? This is branch 1. This is branch 2. This is branch 3. So for each branch, you have to write the current that is flowing through it. So for this branch, there is already a current source of 6 ampere. So there is no need to write that V by R equation. Okay, directly current is given. The current is going into the particular node. So minus sign. How much? The value? Value is 6 ampere. So minus. We don't know. V1 is unknown, V2 is unknown. So we cannot know in which direction current is flowing. According to our convention, if you considering node 1, we will consider V1 to be. That's why V1 will be greater than V2. As a result, current will be flowing out. So plus sign. And V1 minus V2. That V1 minus V2 is the net potential that is applied across this 5 ohm resistance. And the current will be divided by, again, to this branch. V1 and V3. We don't know what are V1 and V3, but we'll consider V1 to V3. So current will be going out of node. So plus sign. What is the net potential that is being applied to 2 ohm resistance? V1 minus V3 divided by 2 should be equal to 0. Okay. So this is the first equation. This is the first equation. Again, now KCL at. Now here the problem lies. Node 2 and node 3. There is a voltage. Cannot write the equation. If you try to write the equation, let us say we are KCL at node 2 here. KCL at node 2 that you are applying. In that case, how to write the equation? Again, for this branch, V2 will be greater than V1 out of this. Okay, current will be flowing out. So this will be plus sign. And what will be the magnitude of the current? V2 minus V1 divided by 5. To this branch also it is okay. V2 will be greater than the ground, 0 voltage. So plus sign, it will be current will be moving out. So V2 minus 0 divided by 4. But what about this branch? How you can write the current? You don't know how much current will be flowing through this branch. Okay. For this branch, this not right. Okay, this thing you cannot write. Similarly, for all the for other branch you can write the current. For this branch, you can write the current. Okay. But what about this branch? There you cannot write the current. Hence, you have to consider, you have to use the concept of super node, and instead of considering node 2 and node 3 as two separate nodes, initially, temporarily, you have to consider, you have to apply KCL at the super node that can be created by node 2 and node 3. Okay, how to create? Temporarily, you do not consider the voltage source. Okay, just remove the voltage source and write the like KCL equation in a combined manner. So How to write that KCL equation? We'll consider V2 first. Okay, we'll consider V2. So it will be V2 again using the same concept. V2 is greater than V1. So plus sign. V2 minus V1 divided by 5. Again, here V2 is the highest. So plus sign. V minus 0 divided by 4. Now, we will not find out the current branch. We'll consider now V3. Okay. Now then for V3, it is for this branch. How much current is flowing? We don't know. We'll consider V3 to be highest one. So plus sign. V3 minus V1 divided by 2. Again, through this branch, we don't know what is V3. We'll consider V3 to be the highest. So V3 will be greater than the 0 volt. So plus V3 minus 0 divided by 10. The sum will be equal to 0. Now in the same equation, we have written it contains both V2 and V3. It contains both V2 and V3. So how to solve? This is equation 1. This is equation 2. Two equation, 3 unknown, we cannot solve. We need another equation. That other equation we can find out by considering that. Now, we don't know V3, we don't know V2, but okay, this 10 volt will be added to V2. Okay, see this plus and minus sign. This is minus, this is plus. Consider V2 to be positive. So V3 will be the addition of V2 and this 10 volt. So V3 you can write as V2 plus 10 volt. Now V2, it can be negative. If V2 is negative, then it will be that negative plus 10. Okay. If V2 is positive, then it will be added with 10 volt. So this is your third equation. That means V3 minus V2 is equal to 10. This is your third equation. So if you use this three equation, now what you have? You have three equation, three unknown. You'll be able to find out the values of V1, V2, and V3. Now just whatever queries you have, please let me know. Okay. Please see how we have written the equations. The circuit is there in front of you, and how we have written the equations. Sir, how we can simply know that we have to apply super node? So when now first you are identifying the nodes. Okay, nodes you have identified. So after identification of the nodes, if you are seeing that there is a voltage source, only a voltage source in between two nodes, then you can say that you have to apply the super node first. Now here we have identified the nodes, first node, second node, third node. Okay, and now you are seeing that there is a voltage source that is directly connected between the second and third node. There are no other elements. In the previous case, if you see this, if you see the previous case, there is this voltage source in between V1 and V2, but along with it, there is a current source. In that case, okay, you can write the current, you can find out what is the value of the current. But here, whenever after identifying the nodes, you are seeing that there is a voltage source that is connected directly between these any two nodes, then that two nodes will make up the super node. Okay, in that way, you can identify that, okay, you have to apply the concept of super node. Otherwise, how you can write the current? Means we tried, but we cannot write what is the value of this current here. So this is a very important concept of solving this kind of equation. is this type of a circuit, and you will face this circuit everywhere. Means later, whatever circuits you will try to solve, this concept will be needed. Okay. Next case we'll consider. See, I am giving you 1 minute. Okay, 1 minute time with the super node. Since I know that is a very important concept, I am giving you 1 minute time. Just look at the problem and see the equations that are written. You are able to understand in any queries you have in the circuit, in the equation. Please let me know. Just I am giving you 1 minute. Okay, no queries. That means I'm considering you have understood. Now the last case, we are moving to the last case, that when uh, this type of problems you will face. Dependent source is a very important concept for your next unit also. When studying the equivalent circuits of different like transistors and everything, those are all the concept of this dependent source. Okay. Now this is a circuit. This is a independent voltage source. Means independent, and this diamond line, that means dependent. Circle inside the circle plus minus. Okay, so this is a source, and also 10 volt is written. Circle it is independent source. Diamond like sign with a plus minus inside it. That means it's a dependent voltage source. It's a dependent voltage source. But on what factor it depends on? It depends on, just beside it you can write 5Vx. Now you have to see what is Vx. Vx is shown here. Vx is shown as a voltage drop or voltage across this 2 ohm resistance. So definitely it is a voltage controlled voltage source. It's a voltage controlled voltage source. Now how to deal with it? You first, if you are doing nodal analysis, that means the first thing you do is identify the nodes. Okay, V1, V2, these are the two nodes. This you consider as a ground, this you consider as a ground. Again, you are writing the equation. Okay, for node 1. For node 1, you are assigning voltage V1. For node 2, you are assigning voltage V2. Now let us write KCL at node 1. KCL at node 1. Then V1 is the highest voltage. This is the ground. This is the ground. So V1 will be greater than all other voltages. So V1 minus this voltage source is there. So to find out current, we have to see that how much, what is the net potential across this 10 ohm resistance. On one side there is V1, on the other side there is 10 volt and this 0 volt. So 0 volt you are not adding. Okay. 0 volt is not being added to the 10 volt. Okay, so one side of the resistance is V1, the other side of the resistance is at 10 volt. Okay, now we have to consider that V1 is the highest or the greatest value V1 among all other voltages. So V1 will be greater than 10 volt. So V1 minus 10 divided by your 10 ohm resistance, and since V1 will be greater than 10 volt, the current will be moving out, so plus sign. Again, in this branch, V1 will be greater than this 0 volt. So plus sign, current will be moving out. So V1 minus 0 divided by, okay, V1 will be greater than V2. V1 will be greater than V2. So current will be going out of this node. Forget about this arrow. Current will be going out of this node. So plus sign V1 minus V2. That will be equal to 2. And through this branch, current is entering. This 2 ampere current is entering this node. So minus 2 will be equal to 0. Okay. So you can simplify this. V1, this one same equation, V1 minus 10 by 10 plus V1 by 5 plus V1 V2 by 2, that will be equal to 2. Okay. This minus 2 you can take on the other side. Now you are applying the KCL equation at node 2. Okay. So unknown voltage is V1. So let us consider this branch first. This branch current is going out, 2 ampere current going out. So plus 2 to this branch. Again, V2, now we have to consider V2 greater than V1. So current will be going out. So plus sign V2 minus V1, and what is the value of the resistance? 2 ohm. Here, current will be moving out of this node. Current will be moving out. But this is at 0, this is at ground, but there is a voltage source. We don't know its value, exact value, but okay, this is a dependent voltage source. So what will be the current value? Plus sign, plus, because V2 will be the greatest, any value of Vx, we consider V2 to be the greatest. So V2 minus 5Vx, okay, minus 5Vx, this is the dependent voltage source divided by 4. That will be equal to 0. Again, same as this equation, that is V2 minus V1 divided by 2 plus V2 minus 5Vx divided by 4. And this 2, this plus 2, you are bringing on this side, so it will be minus 2. Same equation. Now, what are the unknowns? V1, V2, and Vx. These are the unknowns. V1, V2, and Vx. These are the unknowns. We have only two equations. This is equation 1, this is equation 2. Two equations, 3 unknowns you cannot find. So you have to write another equation. That means what is the value of Vx? If you see, what is Vx? What is the Vx is the like voltage across this 2 ohm. V2, Vx, you can see it is the voltage across 2 ohm, and there is also sign is given to you. What is in which direction Vx acts? Okay, so according to the sign, you can write Vx to be the difference between V1 and V2. According to the sign, okay, V1 is the Vx is the difference between V1 and V2. If the sign was in opposite direction, then it will be different. That is, Vx would be V1 minus V2. See, since positive is on this side, then that means it is denoting that V1 will be greater than V2. If V1 is greater than V2, then only the Vx will be like this. If V2 is greater than V1, then plus sign will be on this side, minus sign will be on this side. So based on the these polarities, or the positive and negative sign that are given in the problem, we can say that V1 will be greater than V2, and V1 minus V2 will be equal to Vx. So this is the equation, third equation. So if you put this value of Vx here, if you put the value of Vx here, that means V2. If you put the, then both the equation have unknowns. We have removed two equation, two unknowns you can solve. Okay. Now Vx is equal to V1 minus V2 based on the sign that is given to you. Okay. Now, two equation, two unknown, you will be able to solve what is V1 and V2. Yes. If you have any doubt, please let me know. If you have any doubt, please let me know. If you have any suggestion, like, okay, the teaching should be like in this way, or this is in that way I have to teach, please let me know. Okay. As I am always open to suggestions. Definitely in another 2 weeks time, the things will be different when we'll come to like physical classes, then it will be different. Now, okay, there is always a gap because I cannot see your face. Means whether you are able to understand, I can see your face, I will be able to understand that, okay, whether you are understanding or not, whether you know the previous concepts or not. But here, there is no such way. Okay. So that's why, yes, there are limitations, but in another 2 weeks time, when we will move into more important things, like unit 2 is very important, by that time, you will be here. Okay, so it's uh, in that way, it is a good thing. But you have to use, like I'm also giving in the classroom, the first thing, Google Classroom. I've already, if you see the chat, I have already given the link. If you go to the like start of the chat, you can get the classroom link. Please join. Still, there are some students who have not joined. Can you share the? I have already shared the notes. Assignment I will share. I have already shared the notes. If you go to the Google Classroom, you can see. Okay, definitely I cannot share the notes before teaching them, but all other previous notes, now the nodal analysis part also you will get by today. So there you can get the recordings, you can get the notes. So please join. I can still see that some of you have not joined. Okay. Later you cannot give the excuse that, okay, I didn't join, that's why didn't I get, because exam will come. Okay. In October there will be exam. If you don't start preparing from now, it will be very difficult because this course has many different things. Okay, unit 1 is like circuit analysis, unit 2 is like semiconductor devices, unit 3 is IC. Okay, so there are many things that are there. If you don't study like regularly, it will be very difficult to score in the class, in the exam. Okay. In that case, if you have any doubt, like in which book you have to study, what is the syllabus, everything is there. But still, if you have any doubt, please let me know. In mail, I am also giving you my I'm also giving you my contact details. Okay, you can also call me. Okay, call me, message me. This is also my WhatsApp number. You can just text me. Okay, about your doubts. All units we have to complete in same one. Yeah, this whole subject has all these units. These 5 units are there in this subject, so you have to complete in this yeah, in this semester only. This semi this subject belongs to first semester, so definitely you have to complete all the units of this subject in the first semester.
तो सर मिड सेम में सिर्फ जो है यूनिट 1 ही आएगी?
मिड सेम में यूनिट 1 और यूनिट 2 का आधा पार्ट मान लो. Okay,
ओके सर.
or unit 2. It's depends on when the mid sem will be there. If it is October, in the initial part of October, then I think half of unit 2. If it is the end of October, because your session has started late, I don't know when the exam will be there, but it will be in October, either in the initial part or in the later part of the, yeah. So based on that, definitely unit 2, some part of unit 2 will be there and complete unit 1. Yeah, so I will take the attendance. From tomorrow, we'll start our next topic. Nodal analysis, mesh analysis. You will get all the notes and the video lectures by today. Okay. Video I have already, whatever I had, I have already uploaded. This today's video I will upload, and this material. These things I will upload just now. Just go through it. Let me know if you have any doubt. Because if you have doubt in this part, in the next part, things will be very difficult. Because new concepts will come, and using all the concepts, you have to solve the circuit. Using nodal analysis, mesh analysis, new concepts, it will be very difficult. Okay. So, roll number 1. I'm sorry, up this. Let me see here who are there. Apurva is there. So Apurva, Arin is there. Devanshu. Forsame. Forsame, have you joined the Google Classroom? Forsame. I think you have not joined the Google Classroom. Please join it. Manisha Bharti. Nelson. Putigari. Pratik Raj. Rajveer. Shashi Sekhar. Shreya Yadav. Yasvardhan. A. Vishnu. Akash Rai. Akhil. Anak. So I have given the attendance for Akash, Anag, Apurva, Arin, Devanshu, Forsame, Manisha, Nelson, Pothigari, Rajveer, Shashi Sekhar Mishra, Shreya Yadav, Tamarapu, Akhil, Pratik Raj, Shashi Kamal, Yasvardhan, and uh, Vishnu. Shashi Kamal is not there, I think. Shashi Sekhar is there, but Shashi Kamal is not. Yeah, Shashi Kamal is not. Yes, I have given you attendance, Anand. Yes, okay. You can leave and you can start your next class. Join your next